Hello and welcome to the final part of this BI4ALL evaluation workshop. We call this Part 99 because we have 6 previous parts, but we don't know if we might in the future at some point in time insert more parts to explain more things about the data models or explain more things about the applications or anything else. So we call this Part 99 to allow ourselves to insert more parts. So, welcome to Part 99 of this BI4ALL evaluation workshop. This is a workshop for you to make your decision as to whether you want to invest in BI4ALL or not. And we hope at the end of this workshop you'll be able to make a decision. Now, in this final piece, I want to talk firstly about the issues of analytical applications and the issues that were faced in 2000 to 2002 about these applications. The big issue was the cost of customization of the application itself. And there are 3 areas of customization that drive up costs. Clients wanted the front-end applications customized, and this caused customization of the model, and this caused customization of the packaged ETL, because many of the people who brought out packaged applications also brought out packaged ETL and tried to sell packaged ETL with the application. Now, what's the cost of application customization? It's a customization of logos, colors, fonts, etc. to conform with the standards of the organization that you're selling to. And in some tools, this is incredibly hard. Business Objects is an example where it's very difficult to customize business object reports to the standards of the customer. So the reports most organizations, the reports have to conform to the standards already established, because most large organizations have very well established reporting standards. You have to deal with multi-currencies in many situations. You have to have user-based security. You have to support multiple languages. You have to support complex calculations. And you have to generate gauges and charts and other graphical data. And this was very difficult to do in most of the tools. Business Objects, MicroStrategy, and Cognos were quite poor at doing these things. When Report Services came out, Report Services from Microsoft, it's actually quite easy to do these things, and that's one of the reasons why we picked Report Services when we did this. The cost of model customization, I often say to people, spare me. My days of doing data models in Power Designer or Irwin or any of the others, I'm not picking on Power Designer in any way, shape or form, it was a case of click yourself to death. You had to click on so many things to make changes in data models. It used to drive us crazy. When we were thinking about building BI4ALL, one of the few things that we all agreed on right up front was we are not going to use a data modeling tool. We have had enough of those. And so we didn't. We actually built the first version of the model just in views. And the views that you've seen in this presentation, the description, the view code, was built as the first iteration of the data model. And we said, well, we'll build a set of views for this data model, and if we can then sell this set of views, then we'll move it into Excel. So we didn't want to use Power Designer or things like that, and it's just very time consuming to maintain these kind of models in those kind of tools. The regeneration of the physical tables and the update of the physical tables is also very time consuming and expensive. The issues of maintaining test data in the face of change is very expensive. Too many tables, and the diagrams were beyond comprehension as the models got more complex. So when you did model customization in these things, hundreds and hundreds of hours go into, quote, updating the data model, end quote, both in the case tool and in the database. And that was an issue. The cost of ETL customization, the source to target mappings defined at field level in code. So these analytical applications had an ETL subsystem where they said, if you put the data into this staging area this way, then we can get it into the data model for you. Of course, in an ETL subsystem, every field is named. So all changes had to be changes to code, the ETL code, and had to be managed accordingly. And the cost of changing the ETL code outweighed the creation of the code in the first place. Okay, so what we did was we said you're better off to have prototypes of the data models and write the ETL from scratch for each of the implementations that you do. And CTL came out of that. So it's hardly a packaged solution when the ETL changes were taking 30 to 50 work weeks. Okay, so the fastest ever effort that I had prior to using CTL was 26 work weeks to write the ETL, write the new set of ETL for a customer. So 26 work weeks to write the ETL, that's half a year. Okay, and that's how long it used to take. That half a year was the effort used in Saudi Telecom. That's how long it took. So before we had CTL doing what it was we really needed it to do in 2004, you were looking at half a year to write the ETL subsystem for a packaged application. So how did we solve these issues of these analytical applications? So we addressed these three issues. All objects on reports, this is in our report services example, which we are no longer selling, but there's no reason why you shouldn't learn from it, right? So all the objects on reports have settings via the custom assembly. So fonts, sizes, colors, highlighting lines, etc. are all defined in a custom assembly for our analytical apps. Stored procedures were used for the report. Stored procedures are used so the report has no knowledge of the underlying data structures that should be so. So report services reports that we did in our custom apps have no knowledge of what the database looks like. The report is completely disconnected from the database, and we created what we call the data access layer, which is the stored procedure layer between the reporting tool and the database. So we can put any reporting tool on top of our BI4ALL data models, because the reporting tool can access, if you so choose, the data model through the data access layer. And using this data access layer made a huge difference in the cost of customizing the analytical applications. So we would suggest, if you are thinking about building custom applications on top of our data models, that you look into our data access layer and how we've done that and the stored procedures, because you may choose to go the same way. So the report and the data are loosely coupled, and we say that repositories like Business Objects, MicroStrategy, Cognos, the data model abstraction layer just get in the way. Now, what we also did was we passed the authenticated user ID into every stored procedure. So the stored procedure has available to it the authenticated user ID in case you want to apply security inside the stored procedure itself. And this is a really important concept. You can say we can define security rules in a table, and then we get past the authenticated user ID, we can look up the security rules, and then we can apply the security rules in the stored procedure, which the user has no ability to see, right? And the reason why you want to do this is that then you don't need to use the database security in order to hide tables or fields from the individual user. The user has no access to the data warehouse, only has access through a front end. The user, he or she, can see what they can see through the front end. So you don't need to set up security rules in the database. Okay, you can set up, meaning the database supported authentication security rules. You don't need to use those. What you can use is just the authentication rules that you define that get looked up by the stored procedures and then implemented through the stored procedures, which is a much, by the way, it is a much better way to apply security if you want to do it that way. Okay. We also did multi-currency, multi-country in our apps. So we presumed that all reports all customers were going to be multi-currency, multi-country, and then of course the ones that are not are using one currency, one country. Calculations are performed in the custom assembly and not in the report itself. The report objects themselves are self-scaling, and we are working on multi-language support. Now, when I wrote this, what we've done for multi-language support in report services is we've created the ability to have one report services report and then to replicate that through up to 10 languages through CTL, through workbooks. So you can write a single report in a single language for report services, and then you can translate it into up to 10 languages, and we support that in CTL. Because report services itself doesn't support multi-languages very well. Now, to reduce the cost of model customization, all models are based on views, and at the time it was just a text document. It's now an Excel spreadsheet. There is there is an extremely small number of physical tables and an extremely large number of views. So now there's, I think, 12 physical tables in the model out of the box that you get to work with, and then there is 846 views over the top of those tables, and so you only, during the development process, you only manage a small number of tables, and it's not until you start pushing some real data, some significant data through the mappings that you create, that you need to break out to more physical tables. So everything is linked to everything, the mesh, so there's no need to keep the model in your head, and so we can develop models as complex as we like. And this was a huge breakthrough, and it means our cost of model customization goes down. Meaningless names in the underlying physical tables means full reuse of the columns in the tables, and it removes the large number of nulls problem that we had in Oracle databases when we were using the prior versions of these sorts of models. It's much faster. The cost of model customization, it's much less because it's far faster and easier to customize. When this slide was written, you only edited a text document. Now you're editing an Excel spreadsheet. And it's finally converted to the real model at the end of the development process. So the Excel spreadsheet generates create table statements and create view statements and things like that. If you want that to go into a case tool at the end of the project and then manage your data model in a case tool at the end of the project, you're welcome to do that. But during the development of the initial version of the data warehouse model, you would use our tools because our tools will get you there faster. And if you have a standard for data modeling tools, you use our tools to get you there faster, and then just migrate to the standard modeling tools for support and maintenance as per usual. The cost of ETL customization, we wanted, when we first sat down and thought about this, we wanted an ETL tool that was 10 times more productive than the next best ETL tool. That was the mark. We wanted it to be 10 times more productive. Well, we've outdone ourselves. So in all ETL tools, when you're building an ETL subsystem, you have to document the mapping somehow or other. So if you have 3,000, 4,000, 5,000 fields that you need to map from some operational system into your warehouse, you must have some kind of mapping documentation. You can't do that stuff off the top of your head. It does take a lot of time and effort to think about this piece of data that I've got, where am I going to put it in my data warehouse? You have to write that down. So we used to write it down in Word documents, then we migrated to spreadsheets because the Word documents became unwieldy. Okay, so what we did with CTL, the C++ version, was the ETL tool discovers the mappings at runtime. There was actually no mapping. The mappings were in the spreadsheet. The spreadsheet created views, and the C++ engine generates the map by name at runtime. Now the SQL generation engine generates the mapping at design time as SQL code. So what got generated in C++ is now generated into SQL and pushed into the database. So there is actually no work, there is no work from documenting the mapping to having the mapping executable inside the database. So everybody else who's using an ETL tool must document the mapping, then implement it into an ETL tool. And that implementation into an ETL tool is essentially a coding phase, and we don't do that. So not only are we better than 10 times faster, we're kind of very significantly faster because, and you may say infinitely, but it's, it's 100 times faster because we actually don't have an ETL tool involved. We have a documentation workbook and we have a generator which generates the code, and that's it. That's what we have. And this means that the ETL coding phase is disappeared. So we are much faster at the ETL coding phase than anybody else. We are the same rate. We're no faster or slower than anybody else in terms of figuring out the mapping process. Okay, now sure, we have a data model to aim at, and so because we have a data model to aim at and we understand the data model we're aiming at, we do map things faster than trying to invent the data model while you're creating your mappings, right? So we are faster from that perspective, but we're no faster than anybody else who had that data model and understood it and had the source data and understood it and was writing the mappings. The documentation phase is about the same effort regardless of who's doing it and what you're doing. So the summary for what we're able to do around the analytical applications space is we are able to prototype ETL subsystems at about 1/10 of the cost of full development with things like Informatica or data stage type tools. Roughly 1/10 the cost. Now if you then want to use Informatica or data stage, that's up to you. Now we can make the prototype production, or we can then recode the ETL into some other tool. So CTL allows us to build the prototype ETL subsystem, and what you do with that as to moving it to production is really up to you. Given that we're generating SQL, you can move the SQL to production, or you can recode that into Informatica, data stage, whatever tool you want, and compare the two sets of data being produced and then go into production with your vendor ETL tool. That's what you can do. So I just wanted to add these slides, the history of cost of EDW BI projects, because in hearing our story, I want you to understand how big a change it has been from what it used to be like. So EDWs have been expensive to build in the past. The world's largest corporations are littered with the remains of failures. People still talk about data warehouses have a 50% failure rate. No one ever said building an enterprise data warehouse was simple and easy. I don't remember anybody ever saying that to me, because they've always been very, very difficult. Three major vendors, IBM, Teradata, Sybase now into SAP. SAP stabilized the models from Sybase, so there's really IBM NCR, and then you've got Oracle SAP, where their data warehouse offerings are really just aligned to the ERP systems. So nobody's actually selling many copies of data models. Data models never made any money for anybody. Analytical applications, Informatica and business objects tried and failed. Oracle is still trying. Cognos, being IBM Cognos now, but let's call it Cognos so you know, has also now exited the space, and there are rumors that others are doing something, but analytical applications kind of went nowhere. The problem of breakthrough cost reductions are difficult to reduce costs, building consensus on requirements. The costs of hardware are reducing, but at a steady rate. Cost of software is rising, and the cost of people is rising. And half the money goes into ETL development and maintenance. So this is the problem. So the problem of analytical applications are customizing the screens reports, customizing the model and ETL, and that negated the value of the application itself. So the only area we are likely to get these benefits are in the area of writing ETL and in the area of customizing the application themselves. So if we just consider the ETL portion only of a warehouse project, in the early 90s, Metaphor was earning $1 million US services per project to implement 10 or 12 fact tables and 15 or 20 dimension tables. That's how much it cost to write the COBOL back then for data warehouses. The services guys at Metaphor were making more money than the software guys that's selling at the front end. They were selling the software at the front end, but making more money out of doing the services to get the data into the data warehouse to present it at the front end. It was an amazing concept. So in 1994, I did a project and it took 18 work months to implement 4 or 5 fact tables and 10 dimension tables. We wrote the COBOL from scratch and it was extremely difficult to write. So this is now 20 years ago. We're in 2014. So 20 years ago, it took 18 work months to build 4 or 5 fact tables and 10 dimension tables, writing COBOL from scratch. That's what it took. And you know, I was no slouch at writing COBOL. It's because we didn't understand how to write the code to populate the data model. In 1995, having had this experience, it took 12 work months to do 4 or 5 fact tables and 20 dimension tables, and we leveraged the source code from this project and standardized it as templates to update by hand. In 1997, it took 6 work months to do 12 fact tables and 30 dimension tables. We made the code into templates and wrote a generator to generate the code from the templates, and a data model was passed into the code generator to generate the data model as well. So already we'd gone from, in 1994, 18 work months, just 3 years later to 6 work months. Okay. Now in 2000, improving things as we went, it took 6 work months to build a 70 table archive layer plus 12 fact tables and around 30 dimension tables using DataStage. And this was very fast compared to other projects, and I was a professional services manager of DataStage vendor at the time, so we figured out faster ways to do things in DataStage. But still, 6 work months to do 12 fact tables and 30 dimension tables and a 70 table archive layer. That's what it took in 2000. In 2001-2, we did 12 work months to do 150 table staging area, 30 fact tables and 80 dimension tables. So look at the numbers going up. 12 fact tables, 30 dimension tables. 30 fact tables, 80 dimension tables, more than twice my previous largest effort. This was my first two IWS implementations. So when you start doing 150 staging tables, 30 fact and 80 dimension tables, this was, whoa, this is twice as complex as anything else I have ever done. Then I did another project. This was Saudi Telecom. It took us 6 work months. This was with the very hot off the press first edition of CTL, trying to improve these numbers. So 12 work months for 150 staging tables, 30 fact, 80 dimension tables. Trying to improve these numbers, I sat down and wrote the first edition of CTL. And on the very first project we used it on, we got 6 work months back. So 6 work months for 150 table staging area and 30 fact tables and 80 dimension tables. Using the Sybase IWS models, and we used DataStage and the early version of CTL, and we developed some templated jobs, etc. for DataStage. So massive improvement. 6 work months. That's a lot of time and quite a bit of money, okay, for using these things. In 2004, with the next generation of CTL and a way of editing DataStage jobs via XML, we in 2 months we took 2 months to build 30 fact tables and 50 dimension tables, but no archive. Okay, 2 months. So nearly halving our effort again. And in 2005, 1 work month to do 81 fact tables, 112 dimension tables, 4,000 fields, and moving in the source tables, and moving 2,500 to the EDW with no ODS. And we invented generated runtime ETL, and this ETL was later converted to data stage. So look at this. We went from, where we finished up was 81 fact tables, 112 dimension tables, push the button, basically, to get it into data stage. From 10 to 12 fact tables, $1 million. 10 to 12 fact tables, 15 to 20 dimension tables, $1 million. 4 or 5 fact tables, 10 dimension tables, 18 work months. In 10 years from there to here, 81 fact tables, 112 dimension tables. Awesome. Okay. And now, of course, it's much better. So with the SQL generation, of course, it's just write your mappings, generate your ETL. Now, we take a completely different approach. In the past, the way in which you do your data model development is requirements, model design, write your mappings, ETL design and build your applications. This is the first time you really get to see your data, and if you would like some changes, it has to go back here, so that goes into release 2.0 if you ever get it. And this is all on critical path and takes time. Using CTL and BI4ALL, yes, you can do your requirements, but remembering that you have a very full model to go off, you can do your requirements, you can do your model design, data mapping, ETL design and build, all happens at the same time in the same tool. Okay, so your model design, data mapping and ETL design build happens in the CTL spreadsheet. Now, you can then start your applications building as soon as you start getting some data through this process. So your applications building starts about halfway through your data modeling designing process. As you build your applications, you can build changes into your applications. You can convert CTL to your beloved ETL tool or use the SQL version, and this is no longer on the critical path. So we do all the modeling, mapping, and ETL design build and a lot of apps development at the same time, not running it as a waterfall process. And because we do it all at the same time, we compress the timeline of the project and we reduce the risk and the costs and improve the quality. It's a completely different approach, and it's one that works extremely well. And by the time you build the prototype, you know what you're going to get in production. And in fact, with CTL and BI4ALL, it's extraordinarily difficult to fail. In order to fail, you have to not take the advice of us as the experts. If you take our advice as the experts, you can't fail in a data warehouse project with us. If you don't take our advice, then you may be successful, you may fail. But if you take our advice and do it this way, you can't fail at putting a data warehouse in production. So why is this different? We can generate running ETL from the mapping spreadsheet. The CTL spreadsheet and ETL remain in sync. There is no conversion of specifications to programs. We have reduced the single largest cost of building an EDW and can work in stages in parallel. And I just wanted to show you there are reports, and you have these reports and you can look them up. So the mapping spreadsheet is presented out through these reports. So I won't go through this. I will just leave this here, and I would suggest you hit pause and read through this, because we're now out on thought leadership. This is where we started, trailing edge, industry best practice, what you'll hear from other people, industry leading edge, and thought leadership is what we're doing in BI4ALL. Now, what I want to talk about now is the process of BI4ALL modeling in more detail. In BI4ALL modeling, associations dramatically change the process of modeling. It changes everything. You do not design and build or customize a BI4ALL model the same way you have done any other model previously. If you're going to implement BI4ALL properly, you need a mindset change. on how data models are developed and how data warehouses are implemented. It's a complete mindset change. And this is very challenging for most people because most people take the view that my experience should see me through and I should be able to leverage what I have done before and repeat, maybe with a few changes, what I've done before to get where it is I want to go. And that's not true with BI4ALL. You need to take what you've had before and say, I need to forget that in the processes that I've used before, and I need to embrace this new process that Peter's talking about. And it's going to be a little bit of a challenge and it's going to be a little bit difficult, but once I do it for the first time, then it will be easy to do for the second and third times. So associations dramatically change the way we do this, the process of this, and it makes the modeler's life much easier, much easier. It eliminates some significant problems by design, dramatically enhances productivity, and dramatically reduces development times. So how do you go about this? In BI4ALL modeling, the first thing you do is you identify all the dimensional data. Forget about fact tables for a while. Identify all the stuff in the source databases that looks like dimensional data. What we do is we take all the data that might be in scope, as much of it as we can find, and we throw it into the staging area, right? And we build a staging area which is as big as the machine that the customer will give us to build the staging area on. And if it's a full-size staging area, the more data the better, because then we have better data profiling results if we have more of the source data. So when we go to a client, we say, can you please give us everything that you might want? Doesn't matter whether you do want it or don't want it, just give us everything, all the data you have that you might want in your data warehouse, and that's where we're going to start, on all the data you have available. And if it doesn't look useful and has no value, then we won't put it into the warehouse. Now let's get it into the staging area. And we typically build the staging area as quickly and as rapidly as possible using our CTL tools, and that right there is quite a valuable thing to have. The customer can implement a production staging area, having data from the operational systems flow into the production staging area very quickly or very early in the project process, and we can look into this production staging area or near production staging area to see what all the data looks like. And because you need that production staging area anyway, this is a very handy thing to do. So we look into this staging area and we identify everything that looks like dimensional data, and we start mapping the dimensional data, and we attempt to define unique and discrete values in this dimensional data. And if there are large combinations of values, we break the input data up into smaller dimension tables to keep the number of rows in the dimension tables low. And this is our first step in doing this BI4ALL modeling. Most people, when they approach how am I going to build my data model, approach it from what fact tables do we have, what transactional type information do we have. We need to design the fact tables, and then we're going to attach. Then we're going to figure out how we're going to slice these fact tables, and we're going to attach the dimension tables, which is how we used to do it. And there's no argument that that works. That's how we used to do it. And it is exactly the opposite of how we do things now, which is why it's mentally a challenge to do BI4ALL modeling for people who are used to the old way. So we do all the dimensions first, and then we decide which dimensions need to be type 2 dimensions. And there are usually very few type 2 dimensions because we have the associations and we know that we can associate dimensions with each other. And then we determine the real key in the data for these dimension tables. And once we've figured all this out with the dimension tables like this, we've produced views and we like the way the data looks coming out of the views, etc. Only then do we try and map it to a BI4ALL table or define a new table in BI4ALL for it to go to. So what we've done first is we've scanned and looked at all the data that is there, and we've decided for ourselves what dimensionalizes properly, and throw all this into usually more than 100 dimension tables. Okay, maybe 70, 80, maybe 100 dimension tables. We throw all this stuff into dimension tables. Okay, and we get all that working. And we make sure that we've figured out what we like in dimension tables, yeah? And that's the starting point. And we haven't touched a fact table yet, haven't looked at fact tables yet. Then, once we've satisfied and we've moved well along with dimension tables, we look at fact table modeling. And we go through all this data again and we look for the transactions. And we model all the transactions first. And transactions are usually fairly obvious in source data, staging data. So we go through all the transactions and measures data and all the stuff that we want to calculate and derive out of the staging table in slices, etc. And we start building the views over the staging area to say, well, this is what we want and this is what it should look like. And these are the fields and these are the derived values. And we don't worry about keys at all. We don't worry about what dimension tables we're going to link them to. And we build the mapping for the fact table and all the derivation of all the fields and everything else we need out of the staging area. And we get the view working, and then once we're satisfied with this is how we want to lay this record down in the data warehouse, then we turn around to BI4ALL and say, is there a home for this thing? And if there's not a home for this thing, we create one. And if there is a home for this thing, we put it into the appropriate table, adding the appropriate columns. And we've not worried yet at all about linking the dimension tables to the fact tables. And in the first early runs of fact tables, what we do is we just put the primary key on the front, dates and times and dates and minutes and things like that we add, because you always have to add those things, yeah? And so the timestamp off the transaction is used to look up the dates and minutes dimensions, but that's it. We just do the primary key, the dates, the date for the transaction, the minute for the transaction, and no other dimensions, and run the fact table, you know, and see what it looks like, and see how it works out, and all the keys in the dimension tables are left empty. And we do this whole process. We build all the dimension tables, we build all the fact tables minus the dimension table lookups, and we get that whole thing working as a prototype. And then only after we've got that whole thing working as a prototype, or maybe we stage it depending on how many people we have available, etc. After we've done all that, only then do we start connecting the dimension tables with the fact tables through the lookup process through the CTL spreadsheet. Okay, and typically that'll be 700 or 800 lookups that have to be coded and tested and made sure they work, etc., etc. And that takes a while to do, but it's very straightforward. You just go into the spreadsheet and you have to prepare the string key on the input table, on the input view, to go into the lookup process to get the correct key. But what I want to emphasize is that during this whole process, when you're building the dimension tables and then the fact tables, you make the fundamental assumption that if two things are supposed to be linked, they will be linked and it will be easy to do. So I don't need to worry about that now. I'll do that later. And that is such a radical change from what we used to do, which is we need to define our data model, we've got to have pictures of it, we've got to define our fact tables, and then we've got to link our dimension tables to these fact tables and get all that to work. This is diametrically opposed to that, okay? And people who are still doing this, the old way of building the tables and linking the dimension tables to them and drawing diagrams, etc., people who are doing that, they have a hard time embracing doing it in a diametrically opposed way. They have a hard time embracing that, okay? But that's how it is. When it comes into modeling history, what you do is you identify the areas where you want to retain history. Entities, parties, and accounts are already defined. You might add things like end of month outstanding balances, daily outstanding balances, and things like that. You decide how you're going to retain that history. Is it a type 2 dimension table? Is it a new association table? Is it an event table with current previous amounts? Things like that. So once you've built your prototype, then you start looking at it and going, which history do I want to retain over and above my transactions and my measures, and how am I going to retain that history over and above what I've already done with my type 2 dimension tables, etc. So you do the history modeling right at the end. So BI4ALL modeling is way faster. Once you adopt the ideas and techniques of BI4ALL, modeling in BI4ALL is far faster, far easier than any other current methods of designing data models. It also produces a faster and cheaper enterprise data warehouse for no loss of functionality. So I showed you a diagram many hours ago at the beginning of this evaluation session. I showed you a diagram, and I said that we could do away with the archive layer. Okay, you will remember this diagram from earlier in the evaluation process. I said that we take data from the operational systems, get it into our integration transformation engine, however that is, maybe push it through an ODS in third normal form, and this is best practice since 1996, so this is nearly 20 years ago now. And then you build a third normal form archive model, and this is equivalent to the data vault that Dan Lindsed talks about. You can build a data vault, you can store older stuff in third normal form time variant model, so you can take this stuff, build a data vault, which if you want an archive, I will say this and say this publicly, and I have said this publicly, if you want an archive which archives everything perfectly, but you don't want to query it so much, Data Vault is a really good idea. I quite like Data Vault. It took me about half an hour to read Dan's work and understand what he was doing with Data Vault, and it's very good work, and I'm full of praise for what Dan has done with Data Vault. Only trouble is, Data Vault is not really a data model that you want to query. So if you want to use Data Vault, fine, and this is exactly what it is. Data Vault is a third normal form time variant stability analysis style model. That's what it is. And I put in plenty of data warehouses that look very close to that, so I certainly can't criticize it. If you want then dimensional models, you have to take the data up through another ETL process to have lightly summarized star schemas and highly summarized star schemas. This is quite easy code, this is quite difficult code. So I said in 1996 this was discovered, as far as I know. I didn't hear anybody, I've never seen anybody claim that they had this diagram before 1996. I have seen plenty of people claim they invented this idea post 1996 because the idea was spreading around, and a few people claimed it. But if anybody can show me a slide where they can prove that they did this before 1996, I'd like to say congratulations, because I thought it was a really good idea. Now, what I said earlier was we can make the ODS star schema, we can make this star schema, we can make this star schema, and we can have pretty much only virtual models here, put them in here, maintain them for 3 to 5 years, maybe longer. Now we're getting faster, cheaper machines, and much easier ETL processing. I made that claim. Now this claim, now that you've seen associations and the ability to take a string of information and break it up and archive it through a set of keys where the keys can retrieve that information back out of the dimension tables, it should be obvious to you that this can be a dimensional model, okay, and that there is no need for the data vault or the archive. Now, when I say there is no need for the data vault, obviously if we're trying to do everything, an ODS, archive, dimensional model for querying, all in one data model and one set of modeling techniques, it should be obvious there are compromises. Okay, people have said to me, oh well, if I have to make a compromise then I shouldn't use the model, and I'm like, spare me. I've been in IT 32 years now. It has always been a compromise. Everything we've done has been a compromise over those 32 years. It's a compromise between how much does it cost to do it, what's the benefit of doing it, is the cost benefit worth it? And if the cost benefit is not worth it, maybe we can compromise some more to reduce the cost, as long as we don't compromise the benefit or the quality as well. And so this balancing of cost benefit compromise is something that we have been doing for a very, very long time. So when people say to me, oh well, the data vault is perfect archiving, and I don't want to compromise on my perfect archiving, so I should have a data vault and another dimensional model. And the answer is, well, yeah, the answer is we had that in 1996. We had that, and there is a cost profile for building this, and if the cost profile is in excess of the benefit profile, you can't get the business case approved to build this. Now, if you compromise and you build this at about 50% of the price of building this, okay, remember, building this versus building this has a 50% or more price differential. Given a 50% or more price differential, the question is, are you willing to compromise a little bit in order to get the 50% price differential for no loss of functionality, or virtually no loss of functionality? If you wanted to build a data vault using dimensional modeling techniques, if you wanted to build a full archive using dimensional modeling techniques, you most certainly can do that. Okay. Again, there are a few compromises involved in that. So the question is, for a 50% reduction in cost, are you willing to give up a little bit and give up a little compromise, make a few compromises, with the financial disadvantage being quite small? Now, when put in that terms, the answer is often yes. Okay, we'll take the 50% lower price tag, thank you very much, and we'll do without a few bits and pieces, and that's okay. Otherwise, everyone would be driving Lamborghinis and Ferraris around. If you never wanted to compromise on your car, people would be driving Rolls Royces, Ferraris, and Lamborghinis. But the price of the Rolls Royces, Ferraris, and Lamborghinis means that in fact, people drive Hondas and Fords and things like that, VWs and things like that, because they're 10 times cheaper. When the price of the car is 5 or 10 times less than another car, people don't say, I don't want to compromise on my car, I'm going to buy the €500,000 car. They say, I've only got 50,000 euros, so I have to buy the 50,000 euro car, right? Something like that. Or the 30,000 euro car, or the 10,000 euro car, whatever it is that their budget is. So with BI4ALL, you get to build your data warehouse at a budget vastly less than if you're building archive using a different data modeling technique. So this is our new BI4ALL proposition, and it's a very compelling one. You get increased query performance because attributes are broken out to type 1 dimensions and joined directly to fact tables. All joins are through the integer keys, and there's almost no type 2 dimensions. You can support ODS and DW query patterns. We've used these models to build ODSs. Now, when you build ODSs using these models, your question is, can you do this in the time frame that's acceptable for the ODS? Now, in telephone companies and retailers, doing this once a day as a batch is perfectly acceptable. In a bank, it's a little less acceptable because this might be your credit score. This might be an overall credit score. But certainly in a retailer or a telephone company, a web shop, things like that, this being once a day overnight is perfectly acceptable. There's no reason, there is no great reason why you want to do this more than once a day in a telephone company or a retailer. You do not have to build data marts. You can answer all your queries directly from the ODS in Warehouse, and approximately 40% reduction in ETL coding and maintenance. And so not only are you getting a smaller, less data redundancy solution, you're getting a solution with far less ETL coding and maintenance, as well as doing that coding and maintenance far cheaper. So you are actually reducing the ETL code and maintenance, and you're reducing the cost of the reduced coding and maintenance. And you avoid hardware software costs for data marts. All data is readily available through end user tools, even the archival data, because it's all stored in star schemas, and everybody in the query world has adjusted their tools to be able to read dimensional models. So you get that. So we come to the end of this workshop. And if you've listened to all this, I'd like to say thank you very much for listening to me for all this time. I really do appreciate it. I hope that we've given you enough information now to sit down, think about it, talk about this with your peers and make your decision. Yes, we want to go with BI4ALL, or no, we don't want to go with BI4ALL. Because now we're going to go to next steps. Now that you're at this point, what are the next steps? The next steps are for you, Mr. Prospect. I'm not putting any names on here. You, Mr. Prospect, you need to determine the suitability of investing in BI4ALL for yourself. You need to determine which acquisition process you might like to use, whether you would like to use it, if it is yes. So what do you have at this point in time? You have all the marketing materials for BI4ALL. You have a spreadsheet telling you what's the name of and description of each of the tables in there. And we've given you some sample tables and things like that. And we're saying to you, depending on the revenue of your company, you have a monthly license charge rate at the list price. So I just will remind you of that slide. You will remember back some time ago, that was slide number 9, and this is the list pricing. If you give us a reason to give you a discount, a good substantive reason, then we can look at discounts. But depending on the size of your company, if you're a small company, you can license BI4ALL for 1,000 euros per month, 12,000 euros per year. It's a rounding error. That's less than 1/3 of a salary per year you license BI4ALL for. So you can license BI4ALL for a small company at 1,000 euros per month, and then the breaks over 500, over sub 1 billion, over 1 billion, over 1.5 billion, over 2 billion. Oh, that was actually correct. My apologies, I thought I had made a mistake there, and I just corrected it, and I made a mistake in the correction. So under 1 billion, under 1 billion euros, 2,000 euros per month. Over 1 billion euros, 2,500 euros per month. And over 2 billion euros, like if you're a mega company, then we need to sit down and talk. So these are the standard prices. So a small company, even a 500 million euro company, 1,500 euros per month is a rounding error. So you want to stop and think about, okay, well, we've seen this data model, BI4ALL. We know that we can't develop this in any short amount of time. I mean, to develop a data model like this is going to take somebody 12 months, and he's going to be an experienced data model developer, and you may get a similar result and you may not. There's no surety in that, right? An experienced data model developer like this is going to cost you in Europe between 60 and 80,000 euros for the year to do that piece of work, if not more. If you get a external consultant, an external consultant is going to charge you, a good one is going to charge you at least 800 to 1,000 euros a day to design you a data model like this. And heaven forbid you go with one of the big consulting firms, you're going to be starting at 1,200 euros a day for them to be, as the daily rate, for them to be building a data model like this. And they're going to take 200 days to do it. Yeah. So if you hire an external consultant, i.e. one of the large consulting firms, then you're going to be paying 200, maybe 300,000 to get your data model developed. That's what you're going to be paying, okay? So that we make this available to you for 1,000, 2,000 euros a month, depending on your revenue, tells you that this is a very inexpensive way to acquire such a data model. And these options are guaranteed through to the end of these prices are guaranteed through to the end of this year. So you and your colleagues need to think about, okay, well, how much would it cost us to develop this ourselves? Would it be better off us adopting this and this experience? And I would claim that it is very very beneficial to adopt BI4ALL as opposed to try and develop your own data model. That's what I would claim. But of course, I would claim that. Having been doing this for 20 years, of course, I would claim that my knowledge and argument is sound. Now, of course, because you can acquire BI4ALL on a monthly license charge, and then if you decide to implement it, you build the prototype warehouse and you say, okay, well, we like the prototype warehouse, we want to go into production with it, let's move it into production. At the time you move it into production and you understand that you now like it and it's now going to stay here for many years, at that point in time, you have the opportunity to buy the models, okay, as a list price. And the list price will be something like 5 years, the monthly license charge, 60 months. Okay, that's something like that. We may have some negotiations and we may have some discussions, but in terms of making your decision whether you want to buy BI4ALL or not, and how much might it be if we buy it later on, what you should be budgeting on is, okay, we are a certain size company, we're going to license the model for this size company, and we're going to buy it on the monthly license charge because that's a rounding error around here for the project budget. We're going to develop the prototype, we're going to then decide whether we want to put it into production or not. If we go into production as planned, we know we're going to maintain it for a while. We then have the choice of continuing to pay the monthly license charge on an annual basis. So on the first anniversary of the monthly license charge, the payment we've already made, on that first anniversary, we can decide for ourselves whether we want to buy this thing or just continue to monthly license charge it. On that first anniversary, what I would say is the purchase price is going to be approximately 60 months of the MLC. Okay, so while you're making this decision about buying this data model, just think about on the first anniversary, the purchase price could be about 60 months worth of MLC. And if you purchase it and then grow bigger, you don't have to pay more. Okay, if you purchase it and grow past the boundary, you don't pay more. You've bought it, you own it, and there's no maintenance on that purchase fee. Okay, so if you want to go forward, what that would require is you at least purchase a BI4ALL developer's license if you are a consulting firm. Okay, so if you are a consulting firm and you want to then put BI4ALL into your customers, you have to buy a BI4ALL developer's license, and that's the same price as the real license, and that would be, because most consulting firms are under 500 million euros, you would be paying 12,000 euros for your developer's license. You have to purchase CTL developers licenses because BI4ALL is maintained in CTL. And some people have said, well, why can't I just get CTL for free because I'm buying BI4ALL? And that's the same answer as when you go to Microsoft and you ask to buy SQL Server, do you say, I'm buying SQL Server, therefore you should give me the operating system for free? Or do you say, I'm buying SQL Server, therefore I need to buy the operating system in order to run SQL Server? It's the same argument. If you are going to buy BI4ALL, you must buy BI4ALL, you must buy CTL in order to maintain and develop BI4ALL. Okay, so that's what you would require. If you are an end user customer, obviously you need to buy a real license for BI4ALL such that you can deploy it. We charge customers for BI4ALL at the start of the project. Okay, so it's just like if you were going to use SQL Server. When you are going to use SQL Server, they say, here's you can buy a quote developers edition, if you want, and then you buy the developer's edition in order to do your development. Okay, you don't get here's a free SQL server for as long as you like. Although Microsoft does have an evaluation version of SQL Server available, but the evaluation version is not meant to do development on. The developer edition is what you're meant to do development on. Okay, so we say the same as Microsoft, and I think that's fair. You would, if you're an end user customer, you would need to engage IBI to do your training in your first project, or one of our licensed trained partners. We're not selling the BI4ALL data models to people who want to go then and implement it themselves. If you want to do that, we need to sit down and have a serious discussion about that. We would much prefer that you let us build the data model and build the ETL subsystem for your first project, then train you and you support it. Okay, if you want to support it in the future, we would prefer to build it. You can advise us and guide us on that, but we would build it and then hand it over to you so that we know we can make the first project successful. Okay. You can engage us to build your warehouse. You can engage our business partners to build your warehouse. Okay, so that's what you would require in order to get started. A BI4ALL developer's license or a BI4ALL license if you're not a developer, if you're an end user, and CTL licenses for your developers. We are more than happy to answer any questions and explain any items in more detail. I think this is about 7 or 8 hours of video. I haven't added it up. I think it's about 7 or 8 hours of video for this workshop. Plus you've got our sample data warehouse. Plus you've got many other videos, example workbooks, examples of our BI4ALL. We've given you very much everything we can give you in order for you to make a decision. If you can't make a decision with all the information we've given you, by all means ask us some questions, etc. But remember, the amount you're being asked to decide on at the current point in time is just the amount of the monthly license charge for the next 12 months, because you're going to pay for a 12 months monthly license charge, the CTL developers for 12 months, and if you're going to get us or our business partners to do your development work, which we very much recommend, then you're budgeting for that time as well. So the amount that you're budgeting for is really less than 100,000 euros. If all the information that we've given you can't get to a decision for a budget of 100,000 euros, then you're probably not ready to build your data warehouse anyway, or you're probably not ready to migrate whatever you have to our BI4ALL models anyway. It's not like we're asking you for €1 million or €1.5 million to do an entire data warehouse build, which is what the big consulting companies would be asking you for if you went and asked them. Okay? We're not asking you for a significant amount of money or a significant commitment at this time. You get to bail out if you don't like how this is going in 6 months' time or something else like that, 3 months' time, 6 months' time, you get to bail out. You just don't get your monthly license charges back. Okay? You bought it, you own it, is how that works. So this, we think, or I believe, that we've given you more than enough information on which to make your decision. Once you make your decision, then we will plan about how we go about performing the implementation. You may ask us questions about how we might go about performing the implementation. You can look at our methodology presentations and things like that. But this workshop was about giving you enough information for you to make a decision whether you want to invest in BI4ALL or not. And we believe we've given you enough information for that. Okay? 172 slides worth. So let me just summarize the second half of the presentation. We did a very brief first piece, the second half. We did introductions, we talked about the evolution of data models, what did we want to build, we pointed you to a 1-hour video of the reporting applications. We then got into BI4ALL and how do you read the model, and showed you various tables, listed all the tables, talked about the tables briefly. We've given you the spreadsheet which gives you the names of the tables and the description of what goes in the tables. We then walked through each of the 5 models, the base model for BI4ALL, and then we walked you through the telco, retail, media, and web versions of the models. And at the end, I took you through a half-hour discussion on the issues of analytical applications and a half-hour discussion on the process of BI4ALL modeling, because it is so different. Okay, and we want you to understand it is different, which is one of the prime reasons we don't want you to attempt it yourself. Okay, and then we just got into the summary and explained the pricing once more to familiarize you just at the end of the presentation about the pricing and the next steps. So now it's really up to you and your peers to sit down and look at the information that's been presented and decide for yourselves, yep, we want to go with this, and we're going to implement this data model in our organization, or we're going to adopt this data model for our consulting firm, and we're going to go forward. Okay, so that's a decision that's in front of you. Again, I'd like to say thank you very much for your time. I do know this has been a very extensive exercise. If you will understand, I've done this myself 10 or 12 times, and usually when I do this I've usually had to fly to some place to go do this one-day presentation and talk to a group of maybe 8 to 12 people about BI4ALL or the previous versions, previous models, IWS, etc. So this usually has been a very expensive and time-consuming exercise from our point of view. So it's very nice to this time be able to do it from my home office, put it up onto YouTube, give it to you so you can download and understand, and that has reduced the cost of sale significantly, and meaning that you don't have to pay for all the people who I went and talked to who didn't buy BI4ALL. Okay? So I would like to say, if it was a little tedious for you, please remember I've done this many, many times over. So lastly, I'd just like to say once again, thank you very much for your time. I do appreciate that you've sat through this and listened to this and given us careful consideration as to whether you want to acquire our data models or not. So thank you very much for your time. Thank you for listening.